Okay, so you know how everyone's always talking about blockchain speed, transactions per second, like that's the big deal.
Yeah.
But Solana's kind of doing its own thing. They're like, hold on, what about time itself? Like, how do we even track time in this whole decentralized world?
You're right.
And that's where we're diving into today, the Solana Whitepaper. We're going deep. And trust me, this is not your average blockchain hype.
No, it's a completely different way of thinking about things. See, with most blockchains, it's all about how do you get everyone to agree on what happened when without someone in charge.
Yeah.
It's like, imagine trying to get a room full of people to synchronize their watches without anyone being able to tell anyone else what time it is.
Chaos, right?
Total chaos. And that's what most blockchains are struggling with. So how does Solana solve this? Enter proof of history. Yes, this is the big one.
This is the game changer.
It's like, imagine instead of just having a blockchain, you have a blockchain where every single block is linked to the one before it in a way that can't be messed with.
Right.
And on each link, you've engraved the exact time it was created. That's what proof of history is doing.
So no more arguing about the order of events. It's right there, time-stamped with, like, cryptographic precision.
Yeah.
But how do they actually pull that off?
All right, so this is where it gets really clever. They use this thing called sequential hashing. Basically, it's this cryptographic function, super secure, right?
Okay.
And it runs nonstop, generating a unique output every fraction of a second. Each output's like a timestamp.
Wow.
And because each one's fed into the next calculation, it's tamper-proof.
So it's like a high-speed, unbreakable digital clock built right into the blockchain.
Yeah.
That's wild. But okay, hold on. How does a transaction, something I do, how does that get linked to this time-stamping system? That's the part I'm having trouble wrapping my head around.
Okay, so say you make a transaction. What happens is the details of that transaction get combined with the unique output generated by that proof of history function at that exact moment.
Ah, okay.
So it's like they're cryptographically linked.
So it's like a snapshot. The transaction and the proof of history clock, at that instant, they're like permanently bound together.
Precisely.
But doesn't verifying this massive chain, like this constantly growing chain of hashes, doesn't that take forever?
That's the really cool part. See, creating the proof of history sequence, that has to be done step by step. But verifying it, that can be done in parallel.
Okay, so it's like you need one person to write the book, but then you can have a whole team of speed readers to check it.
Exactly, you got it. And that makes verification way, way faster.
Okay, so we have this super precise, secure way of tracking time on the blockchain. And it's not just some theoretical thing. This proof of history is actually integrated into how Solana handles transactions.
It's fundamental to the whole system.
It's what sets them apart.
Yeah.
But that leads to another question. How does Solana decide which transactions are even valid to get added to this like meticulously time-stamped chain in the first place?
And that is where Solana's unique take on proof of stake comes in. It's POS, but with its own flavor.
All right, so we're back and we're diving into proof of stake on Solana because we've got this amazing clock now, right?
Yeah.
With proof of history. But we still need someone or something to actually decide which transactions get added to the blockchain.
Exactly. And that's where proof of stake, or POS, comes in. You've probably heard of POS, right? As an alternative to proof of work, the whole energy-intensive thing.
Yeah.
But Solana, they've got their own spin on it.
So it's like, who gets to be the timekeeper is based on how much they've invested in the clock itself.
Yeah, you could think about it that way.
So in this case, how much SOL they're willing to put on the line.
Precisely. They call these participants validators. And that SOL they lock up, that's their bond, like their skin in the game.
Okay.
And here's the key thing. If a validator tries to mess with the system, they risk losing a chunk of that bond.
Oh, so it's like a security deposit.
Exactly, a high-tech security deposit.
Okay, that makes sense. So they're incentivized to play by the rules because they have something real to lose.
Yeah.
But what is? Like, what if a bunch of them decide to team up, like collude, and try to game the system?
That's the big question, right?
Yeah.
And Solana's got some pretty clever ways to prevent that. First of all, remember proof of history, that timestamping we talked about.
Yeah.
That makes it incredibly difficult for validators to collude because any attempt to change the order of events, it's going to be super obvious.
Oh, because it's like trying to tamper with a security tape when every frame is watermarked with the exact time down to the millisecond.
Exactly. Not very subtle. But there's more.
Mm-hmm.
Solana also has this mechanism called dynamic unstaking.
Dynamic unstaking.
It's awful, I know.
Yep.
But basically, it means the amount of time a validator has to wait to withdraw their SOL bond, it can change. It depends on network conditions.
So how does that help with security?
All right, so let's say a bunch of validators, they do manage to team up, right?
Yeah.
And they're trying to, take control. They're going to want to cash out their rewards as quickly as possible.
Right. Get in, get out, don't get caught.
Exactly. But here's the thing. When the network detects suspicious activity, like a sudden surge in unstaking requests, it can actually increase the unstaking period.
Oh, wow.
Makes it way harder for those validators to escape with their ill-gotten gains.
So it's like the system itself is saying, hold on, something's fishy here. We need to slow things down, make sure everything's above board.
Exactly. That's a great way to put it. And this dynamic unstaking process, it's not just about security. It actually helps Solana recover from major disruptions too. So let's say a big chunk of the network goes offline for some reason.
Okay.
With this mechanism in place, Solana can quickly adjust and reorganize itself, keep things running smoothly.
That's impressive. So we've got this tamper-proof clock with proof of history and this incredibly secure way to reach consensus with this supercharged proof of stake.
Right.
But Solana's not just about security, right?
Mm-hmm.
It's also famous for its speed, really, really fast transactions. How do they manage that? What happens when you have tons and tons of data flying around?
Well, that's where things get even more interesting. They've come up with something called streaming proof of replication.
Streaming proof of replication.
Yeah, and it's basically a super efficient way to make sure everyone on the network has the correct information all the time. But we'll save that story for after the break.
All right, and we're back. We've been on quite the journey with Solana's tech.
It's a wild ride.
It really is. We've got the tamper-proof clock with proof of history.
Right.
We've got this super secure way of reaching consensus with their take on proof of stake.
Right.
But we can't forget, Solana's also known for being ridiculously fast.
Blazing fast.
And before the break, you were about to explain how they handle all that data with something called streaming proof of replication, if I'm remembering that right.
You got it. Streaming proof of replication. It's a mouthful, but it's a really cool concept.
So break it down for me. What is it?
Okay, so you know how in a blockchain, every node needs a copy of the entire ledger?
Yeah, that's kind of important, right?
Pretty crucial. But that's a lot of data, especially as the chain grows, right?
Makes sense.
So Solana was like, okay, what if instead of copying the entire ledger every time, nodes just proved they were storing the data correctly in a continuous stream?
Okay, I'm going to be honest. That went a little over my head.
Okay, let me try another way. Imagine you've got a giant library, right?
Okay.
But instead of checking out the whole book, you just need to prove that you have specific pages available if someone asks for them. That's kind of what's happening here. Solana uses some clever cryptography, like these things called Merkle trees.
Oh, yeah. How do those?
To basically let nodes demonstrate they have the right data without actually sending the whole thing.
So it's like a super efficient roll call, but for data instead of students?
Exactly. You got it.
Everyone knows the information is there without bogging down the network. That's brilliant.
It's a pretty elegant solution.
It really is. But what about running actual programs on top of all this? What about the applications? I feel like we hear a lot about smart contracts and how Solana is a powerhouse for those too.
Absolutely. And this is another place where Solana's architecture really shines. They use this thing called eBPF.
eBPF.
Yeah, it stands for Extended Berkeley Packet Filter.
Itchy.
I know, right? Don't worry too much about the name, though. What's important is that it allows for incredibly efficient code execution.
Okay, so eBPF is like the engine that powers Solana smart contracts,
Exactly.
making them faster, more efficient.
You got it. It's kind of like comparing, I don't know, a race car to a family sedan. They both get you where you need to go, but the race car is built for speed.
And that's eBPF for Solana smart contracts.
Precisely.
So, to put it all together, we've got proof of history, making sure time is tamper-proof.
Right.
We've got proof of stake with its dynamic unstaking for security and making sure the network can handle anything.
Yep.
And then we've got streaming proof of replication and eDPF for handling massive data and running complex applications at lightning speed. It's like Solana took all the best blockchain ideas and just turned them up to 11.
They really did. They weren't messing around.
They weren't. And it's clear they've put so much thought into this. But like any new technology, there's always going to be more to learn. There are going to be challenges, right?
Of course, there always are.
But it is so exciting to see what they're building. Maybe Solana's approach to time and consensus and data, maybe it'll completely change the way we think about decentralized systems.
I think it has the potential to. It's definitely one to watch.
Absolutely. And that is it for our deep dive into the Solana white paper. We covered a ton today.
We did.
Hopefully you all out there listening understand a bit more about what makes Solana tick. And hey, maybe you're even a little inspired by their ambition, because I know I am.
It's infectious.
It really is. And as always, thank you all out there for listening. If today's episode got your gears turning, be sure to check out the show notes for links to the Solana Whitepaper. Until next time, keep exploring and stay curious.